In this video, I'm going to continue topic 8.4, and we are going to look at example 3. We are going to look at the region line between the graphs of sine x and cosine x, and we're going to find the area of the regions bounded by those graphs, and we're going to sketch and shade the region. So first of all, it'd probably be good to know what the sine and the cosine look like. Remember the sine graph, it starts low, okay? And then you go up, and it goes up at pi over 2, and then it comes down, and then it goes below, and kind of does the same curve that way. And then we're going to follow the opposite pattern in the opposite direction. So it's going to look something like this. And then the cosine curve, remember it starts high and goes low, and then down, and then up, and then up. This way it goes down, down, up. So it's going to look something along these lines. And then it basically it wants us to find the area that is in here. And I didn't have them cross very, very accurately. So let's actually do a calculation here. Ooh, don't know what happened. Hang on. All right. So we're going to do a calculation to find out exactly where these cross, because my picture might not be perfectly accurate there. So what I need to do is I'm going to set the two functions equal to each other. So I'm going to set sine of x equal to cosine of x. So I'm thinking about my unit circle. And I'm thinking on my unit circle, where do the sine and the cosine, are the coordinates exactly the same? And I know that's where we're getting square root of 2 over square root of 2 over 2 and square root of 2 over 2. So I know that that happens at pi over 4. I know that it happens at all the pi over 4s, but the one that I'm thinking about that it happens and they're exactly the same at is where they're both negative over here, which would actually be 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, 6 pi over 4, which would be, that's not right. 1 pi, 2 pi, 3 pi, 4 pi. This is 5 pi over 4. But the catch is when I integrate, I can't integrate from 5 pi over 4 to pi over 4. That doesn't make sense. So if I remember when we counted backwards, so it'd be 1 pi over 4, 2 pi over 4. It's also the same as negative 3 pi over 4. So I could go from negative 3 pi over 4. Look at my graph. So negative 3 pi over 4 to pi over 4. So my intersection should have been a little bit to the right there. So my graph isn't perfectly accurate. So I know that my x values are negative 3 pi over 4 and pi over 4. So now let's set that up in an integral and integrate this. So we're going to integrate from negative 3 pi over 4 to pi over 4. And we're going to take the top function, which is, the top function is the cosine function. Look, it's the blue function. So cosine x, and then I'm going to subtract, always subtract, the purple or magenta function, sine x, and then of course we're going to put parentheses around that, put a dx after it. So when I integrate cosine, remember I get sine of x, and when I integrate sine, I get negative cosine of x, and the double negative is going to go positive from negative 3 pi over 4 to pi over 4. So I'm going to start plopping those in there. So sine of pi over 4 plus cosine of pi over 4. And then remember I do a minus and a parentheses. Sine of negative 3 pi over 4 minus cosine of negative 3 pi over 4. So I know that sine of 3 pi over 4, so I'm going back to my unit circle. We're using these radian measures. So square root of 2 over 2. Cosine is the x value. Square root of 2 over 2 minus negative 3 pi over 4 is negative square root of 2 over 2 minus, and then it's another negative square root of 2 over 2. So let's see what happens here. Double negative is going to go positive. It looks like these actually end up canceling out. So that whole back piece is gone. So I really have, when I add these up, I have 1 square root of 2 plus 1 square root of 2 would be 2 square root of 2 over 2. I take that back. I don't think those end up canceling. Okay, so I caught a typo in my work here. I missed, this was supposed to be a plus sign in here, which is going to make it plus negative square root of 2. So what's going to happen is this part still is correct. When I add this piece up here, I'm going to have negative square root of 2 and negative square root of 2 be negative 2 square root of 2 over 2. So this double negative here cancel or goes to positive, and I have 2 square root of 2 plus 2 square root of 2 is going to be 4 square root of 2 over 2. This is going to simplify to 2 square root of 2.